Hey everyone, and welcome to the StarkHack workshop titled Deploying on Madara. Joining us today is Lana, who will be taking us through the session. And with that, I'll pass it over to Lana to get the workshop started. Over to you, Lana.
Hello, everyone. Welcome to the StarkHack hackathon and to the session. So today's session will be about Madara. Madara is my personally favorite project coming from the exploration team at StarkWare. So it is the exploration team. This is our repository, our organization. So on GitHub, keep StarkNet strange, and /Madara will take you to the Madara repository. So it's a project that started out as an experiment, essentially, and has proven itself to be extremely useful, extremely powerful, and it'll basically become the foundation for launching easily app chains, because it abstracts away so much on the one hand from the developer, but at the same time gives a lot of power to configure various parameters that app chain developers may need, and in general blockchain developers. So let's dive right in. So what was the motivation for creating Madara? So if we look at the current transaction flow on StarkNet, yeah, so this is pre-decentralization. Yeah, this is when StarkWare was targeting mainly implementing the whole cryptography, Stark protocol, making sure all the prover and the verifier and the scaling itself works correctly and relatively efficiently. So transaction through the public API enters the mempool, gets validated and executed by the sequencer, gets sent to the prover, the proof is generated, passed on to L1 to the verifier, and if everything is good, then the state update happens on L1 and the transaction is forever in L1. So the sequencer here does its job in the sense that it collects the transactions, packages them into a block, and suggests the block to the state update to L1, right, as a StarkNet block. But what happens is because right now it's just a centralized server, it is obviously not censorship resistant. There are risks of outages, and it definitely needs to be decentralized. And it's not a problem of StarkWare only, but any L2 out there. Yeah, so this was the motivation. And well, the approach to it is obviously to make it decentralized. We want it to be a network of nodes that has P2P, that has a consensus. So what can we do? The solution was to merge together the power of StarkNet, so the whole provable framework, so Starks and the Cairo VM, together with Substrate framework. So for those of you who are not familiar with Substrate, it is a framework created by Polkadot. So it's now actually called Polkadot SDK, and Substrate just became under the umbrella term of the Polkadot SDK. So Substrate is a very, very interesting framework, because it essentially is completely orthogonal to the typical monolithic chains that we were used to when we started working with Ethereum, right? So with Ethereum, there's all the same nodes, all the same EVM. And what does that mean for a developer, right? For a developer, it means that you only decide on the application logic, right? So when you write a Solidity smart contract, you don't have any way to interact with the consensus layer, with the execution layer. So you're limited to this sandbox of, what happens inside the EVM. And the philosophy of Substrate is very, very interesting in that regard, because it allows you to configure whatever you want. Because of the way that Polkadot itself works, that there's a relay chain in the middle, and the different chains can connect to it and have shared security, but we're not going to get into that much. But anyway, the chains, the parachains that exist there can configure their block time, block size, can swap out consensus mechanism, can of course configure runtime logic. And in that sense, it's a very powerful framework. So what we did in Madara is we got the Cairo VM as a dependency into the substrate node. And basically, oh wait, let me just check other questions happening. Oh, okay, not yet. So the Cairo VM became a dependency, and the StarkNet block is essentially packaged inside the substrate block. And because, so right now we have a Madara testnet running, so anyone can try to break it, bombard it with a lot of transactions, and try to execute, I don't know, complicated, deploy complicated Cairo contracts and just try to break it in any possible way. But essentially, so what Madara comprises today is that it exposes a public StarkNet compatible API. So everything they can do on StarkNet, which is declare a contract, deploy a contract, execute a transaction, you can do all the same thing with the Madara testnet or the Madara node template. For those of you who are not familiar with StarkNet in general, we don't save the bytecode of the same contract many times in StarkNet. So when you declare a contract once, like let's say an ERC20, like an OpenZEPL in ERC20, the class hash of it doesn't change. So we declare that once, and then we deploy an instance of it every time when we want to deploy a new ERC20. So we don't store that bytecode many times across the blockchain, which is good. So you can use Madara as a sequencer because once it goes into production and it works as a sequencer, and it doesn't expose any particular business logic in any way, and it just works as a network where anyone can join in and participate as a node in the network to get fees for packaging the blocks and essentially being a blockchain for sequencing. It'll act as a sequencer, but we can also view it as an app chain framework because for example, it is already on the path to be used by two major projects on StarkNet, namely Pragma Oracle and the Kakarot EVM. So it's the EVM written in Cairo. So for example, for Kakarot, it has to be compatible with MetaMask. So that means you can configure cryptography there. For Pragma, because it's an Oracle, it needs a completely different consensus. It has to be much faster, and the block times has to be fast. So these configurations allow people to be very flexible with the type of app chain logic that they want to develop. So let's take a look at the terminal. So I'm in the Madara repo. After you build the node, you can see it all in the repository, how to build and run everything. But what you see is that it starts locally, running on port 9944, and you can see that it starts to finalize and run the blocks. What you can also do, I'm not going to show it right now, but you can also compile the Polkadot.js front end so that you can see the block numbers, just click into the blocks, see the transactions, and especially if you're going to deploy something and invoke the contract. So another repository that I will share is going to be the Madara. Well, actually, it's linked in the Madara repository. So Madara Get Started. It allows you to use the scripts that have been pre-created for you. So here we can declare, deploy, and invoke Cairo1 contracts. So you need to put the Sierra and Chasm files that you can generate with Scarb. You need to put them in the contracts folder, and then you can just simply run the JavaScript scripts. So declaring just happens, you need to import an account. So in this case, this is a pre-deployed and pre-funded account. And then you can just use the declare function and pass it the Sierra and the Chasm. And this way you can declare. So I think it's already declared in Madara from the start. So let's let's try and run it. So declare. Yeah, it's already declared. But if we go and say, hey, can you please deploy this for me? And we pass the arguments. Yeah, so what we get is a transaction hash and the contract address. And I think we're not going to see the result here, but if anything errors, you can see it in the logs. But it is much better viewed with the front end compiled and opened. So of course you can deploy any kinds of contracts, and you can also invoke the contract by using, so you would need the contract address that you get from here, you would paste it into your script, and then you can get balances and invoke any kind of transactions that you need. So yeah, so this is the declare snippet. And if we look at the deploy, yeah, so you need to parse the arguments that you pass to it, and then yeah, what's convenient is also that you can compute the class hash directly from the Sierra file. And yeah, you just pass the constructor arguments and get the result of the deployment with the transaction hash and the contract class. So it is actually quite easy when we're using the scripts. And there's also a faucet. So if you need to transfer funds to yourself for interacting. So if you're using an Argent wallet, for example, you can pass yourself some funds from the pre-funded account and just interact with the Madara instance. And yeah, all the tools are compatible with Madara at this point. So Bravos, Argent. So for example, once you have deployed everything, because you can also deploy some contracts through Argent, I believe, but I'm not sure about passing constructor arguments there. But they're compatible to interact with contracts, so you can basically choose, and also Foundry StarkNet. So all the public tooling that works with public StarkNet is available for usage with Madara. So this is what I wanted to mention. So running Madara, and yeah, so here you have all the installation guides and the links to the Polkadot JS apps front end. And yes, if you also want to be, if you want to run a multi-node local testnet, and Docker and all the other various ways to install. And let me just check if you have the link here to the Madara get started. The script, probably not. I will okay, I will share this. I'll share these links in the maybe in the YouTube description, so that people can grab these, all of the repositories and the presentation. Cool. Well, actually, this was a little bit shorter than I expected. So I am going to look at the questions that we have. Oh. Not able to see the output of the execution of the script. Yes, I can post the links here, sure. So, Madara, these are for the scripts. And can I share this Excalibur? Oh yeah, I can share. Yeah. Copy link, and this is to the Excalibur. Madara is just a decentralized sequencer for the mainnet, but not the prover. I'm not sure that I understand this question because the sequencer has to be integrated with the prover in order to be able to post transactions to L1 to verify them, right? So the proving part isn't part of Madara, but Madara has to post transactions to the prover in order for them to progress further on to L1. So this picture looks exactly the same, except one node. Here we have multiple. Madara can be used for app chains. Yes, it can be used for app chains. So essentially, then it won't play a role of a sequencer because it won't accept all transactions across, like all the StarkNet users. They will essentially, it'll essentially incorporate the logic that the developers want to expose, right? So like I said in the examples with like Kakarot EVM or with Pragma Oracle, they can be they can cater just to a certain subsection of transactions. So they are a sequencer in that sense, but they're not like a global sequencer that collects all kinds of transactions. Madara behaves as ground layer for all layer 2 to make them centralized. Well, the thing is that you could use Madara to settle on other chains if you wanted to integrate them with other provers. So the way it is written, because of the way the StarkNet block is and the way the data is and the way that it's going to be integrated with the our provers at the moment, so it's able to post to L1, but you can definitely rework it in a way so that it can also post to like work for other L2s, but other L2s will have different verifiers because they have different ZK techniques and different verifiers. Can Madara be used for L1, L2 messaging with Anvil? I'm not sure that I can answer this question, but like there is L1, L2 messaging, but regarding you can ask in the Madara group. Oh, let me share the Telegram group here. I think this is also important. So we have a Madara Telegram group where you can ask for issues, get assigned to them, work on things, ask questions, and so on and so forth. So t.me t.me/Madara StarkNet. Okay, I'm not sure if it's a separate network or is the same network as StarkNet. It's not a separate network because it's a part of the network, right? So it's this bit over here, right? So the sequencer, so it's a network that prepares the blocks in a decentralized manner. So you cannot say that it is StarkNet because it's not, because it's missing the proving part. Yeah. Like it doesn't replace StarkNet. Like we also have the public StarkNet, but it plays the role of a sequencer. Like you can have multiple sequencers, multiple nodes in the ecosystem, and they will be like a part of the ecosystem. Oh, I don't know. Am I explaining this well? I guess in your question, it is the same network as StarkNet, because it's going through the same flow, through the same prover, through the same verifier, going to the same state update. Incentive for sequencers on StarkNet. Yeah, so we are working with the Madara incentivization mechanisms. So you will be able to set your key in the sequencer, and you will get fees. The exact fee mechanisms, as in how much and so on, I can't really answer that question, but the idea is that if you're running a node, if you're helping to decentralize the sequencer, then yeah, definitely you're going to be rewarded. But yeah, this is kind of a separate discussion, and feel free to jump into our Telegram chat and ask questions about it, and more people will join in on the conversation. Any other questions?
Also, just to add to Lana, feel free to unmute yourself if you have any questions, or you can also drop your questions on the chat box, and Lana can pick it up for you.
I thought Madara was an L3 network launching solution. Oh, okay. Yeah, I should definitely mention L3s. Thank you for bringing that up. Okay. Okay, so the thing is that when you are deploying a verifier, so right now our verifier here is on L1, so it's written in Solidity. But the thing is that you can also settle on Madara if you have, so we already have the verifier called integrity written in Cairo, written by Herodotus. And when you deploy that Cairo verifier in yeah, this is a definitely more detailed picture. Yeah, feel free to refer to the docs. It'll definitely be more detailed than my presentation. So when you deploy the L2 verifier on Madara, that allows to actually run an L3 somewhere. So it can be just the one node network. But as long as it runs, as long as it creates a proof and it is verified on Madara, in that sense, it becomes the provider for L3s, right? So there are some gaming solutions that are looking to settle on Madara, so to like work as an L3. So we are working towards that, because that might include some work on reworking the prover for that, like that works between L3 and L2 rather than L2 and L1. But other than that, it's definitely, there might be like someone who will build this is actually a great project if you want to test out this flow during the hackathon and deploy the integrity smart contract on Madara and try and run an L3. I think it's a great hackathon project for Madara. So yeah, thank you for bringing that up. Does that make sense? Like how it can serve L3s in that regard? I should probably using developers, try bombarding testnet developers. Oh, okay. Perfect. Yeah, and probably let me just share the integrity repository here for those who are interested in L3s, because this is this will unlock one of the components that will unlock L3s. So yeah, Chiral verifier. Yeah, you can just take a look at the code at the repository and see if you can deploy it. I haven't deployed it yet on Madara myself. So this will be a great exercise. Any other questions?
Cool. If there are no other questions, maybe we can wait for one last minute to see if there are any questions coming in for you. Or else we
Okay.
can wrap up. Seems like an early morning for a lot of people out there.
Right. Are a lot of participants in the US?
Seems like it.
Oh, okay. Yeah, because I'm in Berlin, so it's 4:30 here p.m. So mm.
10 p.m. Oh, we have Zach from Singapore joining the
Ah,
session.
nice. Okay.
Cool. Lana, anything last notes you want to cover, or you're done? Or probably we can just end the session here.
I've used the integrity, it's very good, but the stone prover is not very good. And yeah, the stone prover is definitely not good. If you heard about Stu, I'm gonna also write it in the chat box here. So Stu as in STWO, as in prover number 2, stone number 2. So it is definitely being worked with productization in mind, because we had really a problem, because it was created with just internal usage in mind originally, and then when external projects like Giza, for example, Provable AI, started using it for projects that we started creating, and even inside the exploration team, we were like, oh my god, stone is like a little bit hard to work with. So we're working like the future version of the prover with the circle starks, with the funky math will be definitely like worked with product side in mind. But yeah, this is definitely I agree with this 100%. Yeah, so I hope that like the people who will be listening to this, not live but like later, so that they can ask questions, that they have like a place to address us.
Yeah. So anyone who has any questions after the workshop, they can reach out on Discord on the partner
Sure.
channel. Yeah.
Okay.
Cool. Alrighty. So thank you, Lana, for joining us today and for the great presentation. Big thanks to everyone for joining the workshop from different parts of the world. Feel free to connect with Lana in the partner Discord channel if you have any questions, and they shall get back to you. Cheers, everyone, and have a great weekend ahead.
Yeah. Bye-bye.
Bye bye.